Welcome back to my knowledge share session. Learn with me. Today we are going to continue on the same topic, cloud platform integration. In that we are going to see an important section called security elements. Right, as the picture shows, we have seen a lot of palette groups. In that one you will have called security elements. The security elements contain four things called encryption of a message, decryption of a message, signature of a message, and verification of a message. Okay, just by seeing that you can have an idea what I am going to speak about. Okay, so what does it mean is, whenever you are transforming a message from one system to another system, how you are going to transfer in a secured way. So the secured way contains a lot of things called encrypting and decrypting, or putting a digital signature like that. Okay. In that, first we are going to see about a digital signature. Digital signature, which is called as a simple signer in the iFlow. So iFlow is going to have one palette called a simple signer that will put a signature, digital signature, and that signature will contain some encrypted informations, meaning it is not going to encrypt the body. It's going to have one encrypted signature, and it will be sent to the receiver. And when the receiver receiving the message, first he will verify the signature whether it is correct or not, based on some algorithm. Okay. This is what a digital signature and a simple signer process in the iFlow means. Okay, to do that, how it has to be implemented, what are the prerequisites, everything we will see that. Okay, first of all, what is a simple signature? The simple signature in SAP CPI is a very straightforward mechanism for digitally signing a message, okay, which is very straightforward meaning. What it does is, it leverages a private key stored in your CPI Keystore, meaning that you have to have one key store deployed in your monitoring section. Okay, using that key store, what this CPI will do is, it will create a digital signature and send it along with the message to the receiver, so that it ensures the message integrity and authenticity. That means, when you are receiving a message from a source, and if you are having a digital signature, it gives you a integrity and authenticity. Right? It's very, very straightforward understanding that when somebody is giving you with a signed and sealed thing, then it is authenticated document, right? The same way. So essentially, it acts as a digital seal, guaranteeing that the message has not been tampered with or tampered with and originate from the trusted source. So remember that when you are transferring a message via internet, there are a lot of possibilities to get it tampered or hacked like that, right? To avoid that, we are putting a signature, and we are going to verify the signature at the receiver end with some algorithm, confirming that the body inside that message is not tampered with. So this process is called a simple signer process, which we are going to see that. Remember, we are not talking about encrypting, decrypting. We are talking about simple signing a message, put a digital signature, and send it along with the message, and how the receiver is going to verify the signature and confirm the message. Okay. So why it is important? As I explained already, a message integrity. It ensures that message content remains unchanged during the transit. Authentication, verify that sender identity, preventing unauthorized message manipulation. That means when you are putting a signature, that means the message is coming from a reliable source. Last one is the proof of identity. Okay. To do that, what are the things we have to do it? First of all, we have to create one key store in our manage security section. In the key store, we have to create one key store, which is called a private key, or let us not confuse about private and public. We have to create one key store. That key store will have some algorithm to encryption of the signature. Okay, and that keystore has to be deployed. And in the iFlow process, you will have a payload. Payload you will put it in a content modifier. Not necessarily be a content modifier. It can be anything. For a demonstration purpose, I used a content modifier. In the content modifier, I have my message. Okay. Now I will be creating a simple signature palette. That simple signature palette will have a parameter which uses a key store. Whatever I deployed here. Okay. Using that key store, it is going to create one signature in an encrypted form. Remember, only the signature is in encrypted form. The body of the message is not going to be in encrypted form, which can be read by anybody. So it is going to create one signature and put it in a header parameter of this message. Okay. So finally, when it send it out, in the demonstration purpose, I put it in a data store. So in the data store, when it is received, so it will have two items. One is called body, another one is called a header parameter called signature. The header parameter will have a signature in an encrypted form. Okay, that's it. So what does it contain? What does the signature contain? This signature will contain one encrypted information about the message, and also some other authenticating parameters, which can be anything, using the algorithm defined in the keystore. Okay. Now you got it right. At the time of receiving a message, you will have a message body and you will have a header parameter which contains a signature. That's all. We received it. Now let us come to the receiving side. So what you will do is, so in the receiving side, you will receive a message in a content modifier. Again, content modifier is not necessary, just for demonstration purpose I put it. So in the content modifier, you will have a message read from the data store. So what it contains? It contains a body as well as a header parameter. Header parameter will have the signature. Now what I will do is, I will go to create a signature again as I did it for the previous the sender portion. Okay. So both are going to use the same keystore parameter. So remember, so whatever the keystore you are using at the sender side, the same keystore will be given to the receiver side also. So that when you are recreating the signature, remember, you are recreating the signature again using the keystore. So that what it does is, again it will recreate the signature based on the message received. Okay. Then it will create another header parameter called in the sending header parameter, if you say h1, then the receiving header parameter will have a h2. Okay. Now in the using the Groovy script, I will be comparing h1 and h2 together. If h1 and h2 are matching, that means good, the message has not been tampered during the transit. Okay. Hope you got it now, right? So this is what we are going to do it in the iFlow. Okay. Now let us take one example. Assume that you are going to send some invoice processing records for the payment from the source system. So source system will have invoice process. It will create payment records in the form of XML or JSON that contain the bank information, beneficiary names, everything, right? So that will be pushed to the iFlow. The iFlow will, as I explained to you, the iFlow will use the key store and generate the signature. Okay, using the key store, it will generate the signature, and all together it will be sent to the receiver side. The receiver will have an envelope which contains a header parameter with the signature and body. The body is not encrypted. Body will be a human readable text only. Okay. Now in the receiver side, you will have the same key store. I wrongly mentioned as a public key, but assume it as a key store. Using the key store, here also I mentioned as a decrypting. It is not exactly decrypting, it is regenerating the signature. Okay. So it will regenerate the signature. Now once it is regenerated, this signature and this signature should match. If it match, that means whatever you message you sent, it is not changed in the transit. If you change the message during the transit, then this signature will be differ from this signature, right? So that using the Groovy script, we will be verifying both the signature, and if it verifies okay, both are matching, then it will go for a payment. Otherwise it will not go for a payment, it will be rejected. this is what we are going to do it in the iFlow. The next screen I will go to the iFlow and create the iFlow and show you as a how to create a signature and send it to the receiver side. Probably I will make this video as a two videos, one for sending and one for verification. Okay, now I will repeat again. So we are going to see about the security elements in the iFlow. In that there are four things: encryption, decryption, and signing and verification. We are going to start with simple signature now. Later on we will see the encryption, decryption. This way the body is not going to be encrypted, but only a signature it is going to be encrypted and send it along with the message. So that is called a simple signer. Simple signer is a palette, a straightforward mechanism for digitally signing the message. And why it is important? It shows the message integrity. It is authenticated way of doing that, and you have a proof of sending it. How it works? We are going to generate a keystore. We are going to have a simple signer palette, and using that we will put it in a data store. Data store is not mandatory again, just for demonstration purpose I use my data store. On the verification side, I am going to read it from the data store, and again I am going to recreate the signature again based on the message I received, and I am going to compare both the signature in the Groovy script, and I will take action based on the result. If it is okay, then I will go for a payment, otherwise I will reject it. And this is the example process which we are going to see it. Okay, now I will go to iFlow and show you. Okay, now I am inside the iFlow. As I told you, this is the iFlow which I am going to explain you. I already created. Instead of recreating everything, I just explained you what I have done. So I created this iFlow, but before doing that, as I told you, our prerequisite is that we have to create one key store in the monitoring section, right? So I will go to this monitoring section and I will create a key store. Okay, so I am inside the monitoring section. In the monitoring section, you will have a manage security. In that, you will have a place called key store. Okay, so first you have to create one key store. Sometimes this trial account takes a lot of time to do that. Okay, so once I go to the key store, so manage key store, you will have an option called create. So what you will do is you have to create one key pair. So first create a key pair. Once you create a key pair, you give your alias name, whatever the name you want, you can give it, and the key type is called RSA. Okay, right now I used RSA, DS and EC is out there, so I use the default RSA, and I have a key size of 2048. That gives us a default. The more key size will be the more secured way. That's what it says. So right now I am going with the default value 2048, and this is the signature algorithm. I told you, right, algorithm. So this is the signature algorithm, SHA 512 RSA. So anything detailed about our algorithm, we can review it later in a separate videos. What are all these things? So our focus is now to create a digital signature in this using a iFlow. So I am using the signature, same thing, RHA 512 SHA 512 RSA, right? Then a common name, you can give the same name as what you are giving here, so that you can give whatever the name you want. Preferably give the same name as what you are giving here. And country, in the country region, I gave it as a India. Okay, that's all. This is the only thing you have to give it. Once it is given, then you can say create. Once it is created, a key pair will be created. So in the same way, I already created one key pair called simple certificate. Right? Remember the name, simple certificate. This alias name, we are going to use it inside the iFlow. That's all. The first step is to create a key store. For that, you have to come to the monitoring section and go to the manage key store. In that, create a key store. using the create option. That's all. Right. Once it is created and if it is deployed, so you note down this alias name. The same alias name we have to use it. Okay. Now I will come into the integration section. So this is the iFlow I created. In the iFlow, these are all the things you know already. So I connected with the HTTPS adapter. The HTTPS adapter, I gave the name as connection name as /ss1. Right. So this I will be calling in the post one. So for generating a payload, just I created one content modifier. In the content modifier, there is no header and there is no property. I just give one message. I just typed it. Demonstration purpose, I just created one order ID, a product laptop, and quantity 1. Alright. So this is the message which I am going to send it to the receiver for processing. So in the previous screen I was telling about some payment records. Instead I am just using the order ID details. Okay. So this is the information I am going to send it. That's all. So the first content modifier is having a message. Now we are coming to the simple security. How it does is, see, when you go to security, then go to signature, signer. In the signer you will have a lot of options, which I am going to use simple signer. In the coming videos I will try to create another videos on what all about this signature means. So right now I am going with the simple signature. Once a signature, then it will select it, then put it here. So simple signer palette will be created. In that the properties will be similar. So the alias name, you have to give the same name what you have defined in this place, right? The simple certificate I am going to give it, and it is going to use the same algorithm. Whatever the algorithm you choose here, remember that, and put it in the same way here. And this is the variable name which is going to have in the header parameter. Right now it is showing as SAP simple signature value. You can give your own name, whatever you want. You can say sender signature. You can type it like that also. So this is your naming convention, whatever you want it. That's all. So when the iFlow pass through the simple signature, then before writing into the data store, the message will have whatever the content you passed it here, this value, plus the encrypted signature created by this section, and put it in a variable called SAP simple signature value. Right, that will be a header value, and that will be put inside the data store. Okay. Now what I will do is I will simulate it and show it to you. Then I will execute via Postman and then show it in a data store how it is created. Okay. Then in the further video we will use another iFlow which will read from the data store and recreate the signature and compare both the signatures. Okay. Now I will simulate. Simulation start. Simulation A. I will simulate it. Simulation successfully completed. So beginning of the body will be nothing. Right. After content modifier, the body will be whatever the body I sent it. Right. See, there is no properties and there is no headers. After the simple signature, let us see the content. See, it is created one header parameter called, right? It created one header parameter, SAP simple signature value, whatever name you have suggested here, the same name, it created the value. This is the value of the signature. So see, this is the encrypted form of a signature. Okay, this will be stored. But the data store will not work in the simulation, so right now this will be blank. Anyway, but in the data store it will not be there. At the end of the data store, body will be like this and no properties, but you will have a header thing called header. So SAP data store, the ID will be C001. This is what I defined in the data store. The writing a data store processing I created I say my data store name is SC and my ID will be C001. That's all. Right. For more details about data store, you can see one of my videos there. Okay. So what I will do is, now simulation you can understand now, right? I will execute via Postman. I will execute via Postman and show it to you in the data store. Right. So I will go to Postman. Okay, this I will clear it. So this is my iFlow ID SS1. I'm going to send it. Successfully completed. So I assume that the data store will have my message body as well as one header parameter. Okay. Now let us go to the data store section. I will go to monitor. So there is one data store created one. See, the SC has been created. So the value is created now. Okay. Now what I will do is I will download it. I will put it in a desktop. Okay. So I will open it. See, now it has a body as well as header properties. Header properties, you can see that. Open it in a notepad. See, this is the encrypted value. So okay. Now if you see the body will be as it is. You can read it. It doesn't mean that it will encrypt the body. See, body will be readable. The signature is, the simple signature is not going to encrypt the body. Remember, it is going to just create one signature. That's all. Okay. Now you got it. That's it now. So the sending part is completed now. Okay. So sending, what I have done is I created one keystore, and the simple signature will use the keystore value, and created one encrypted signature and sending it along with the body as an envelope with the header properties. Okay. Now in the another video we will create another iFlow which will read from the data store, and I will verify the signature whether it is correct or not. How we are going to verify, we will see it in the next video. Okay. Hope this section will give you some information about how you are going to generate the signature. Okay. Please update your comments and please update your remarks and questions in the comment section. I will be very happy to reply you back. The more remarks and more comments you give, that will encourage me to do it more in a perfect way. Okay. Thank you so much. Thank you for watching.